In science, observation and measurement produce data. So science is much more than just observation, actually. I mean, it really, description is mainly involved in it as well, but observation and measurement, those are some of the key parts of science, and we're going to be making some observations and measurements today in lab. So an event that happens in the physical world can be described in several ways. It could be described using words as a description. You could collect data. You could create a visual display of that data using a graph. And you can also do a mathematical description. And what I mean by that is an equation. In today's lesson, we are going to be doing all four of these things. So imagine that you had collected data that looks like this. Now, it was your job to interpret this data and figure out what the trends, what the patterns were. Well, that'd be pretty hard. So how can we make this easier? What tool can we use to make reading and understanding this data easier? And so what we can do, and what we're going to do today, is we are going to collect data, and we are going to use that data to create a graph. And a graph is going to allow data to be displayed so it is easier to interpret. So we're going to get this data and we're going to graph it so we can more easily understand and interpret the data. So what should our graph look like? Every graph must have these four things: a title for identification, labels for each axis, units for each axis, and a proper scale, not too small. Honestly, this part's pretty tricky. All right, so again, what does this look like? I'm going to scroll down here. Here's an example. We have our title here. We have labeled each axis, growth, sunlight, and also the units. And my scale here is appropriate. It looks appropriate for this graph. All right, so what are we going to be learning about today? To give you a little bit of background, I'm going to give you this sentence here. Speed is how far you go in how much time. And here is our equation. Speed equals distance over time. We're going to use this today once we get our data. All right, let's do it.
All right, guys, it's time to play. We are going to do our first lab. I'm going to refer to this lab as the Walk Speed Lab. And our purpose today is to gain experience collecting data and making calculations, and then using that data and calculations that we make to create a graph. And then we want to then interpret and understand what is going on in that graph. There are going to be three people joining us today: me, Mr. Boykin, and my mom, the real Miss Moore. And what we're going to do is we are going to measure how much time it takes us to walk 40 meters. And then we are going to write those times in the fastest and the slowest columns, as well as whichever one falls in between in the middle there, just in that time column on the far left. Once we get the times, we will then do some speed calculations and create our graph. From there, analyze the graph. Let's get started.
Okay.
Mom, you're a speed walker. You guys are gonna write these numbers down under this column right here, under time. You're gonna write down under time Patty's numbers, the real Miss Moore. At 0 meters, we have 0 seconds. 10 meters, 6.92 seconds. 20 meters, 14.49 seconds. 30 meters, 21.01 seconds. And at 40 meters, 26.47 seconds. Your paper should look like this. The first one is the starting point, so we're not going to calculate anything. We're just going to put in 0 meters per second. The next thing I want you to do is draw a fraction bar. Then put an equal sign. Whoa, that's an ugly looking equal sign. All right, so we said that speed equals distance over time. So in order to calculate our speed here, we're going to put the distance on the top, which was 10 meters, and the time on the bottom, which was 6.92 seconds. Plug that into your calculator.
How do you do that, Miss Moore?
All right, so we're going to say 10 divided by 6.92 equals, and I get 1 point, we're going to call it 45. 1.45. Do not forget your units. We're meters divided by seconds. Meters over seconds. Okay. All right, let's do one more. Okay. So again, draw your fraction bar. Put in your equal sign. On the top for speed, we have the distance, which is 20 meters. And we're going to divide it by our time, 14.49 seconds. Okay, again, plug this into your calculator. 20 divided by 14.49. And I get, I'm going to call it 1.38 meters per second. You guys are going to finish up the last two. Go ahead and get them. Meters. 20 meters. 30 meters.
Got it. I love this.
40 meters.
Got it.
Under the slowest, you are going to write down Miss Moore's numbers, Val, me, for 0 meters, 0 seconds. For 10 meters, 11.52 seconds. For 20 meters, 21.46 seconds. For 30 meters, 31.91 seconds. And for 40 meters, 41.25 seconds. Ooh, slow.
One, two, three, finish!
Woo! The moment you've all been waiting for, the fastest walker of the group, we have old man, Mr. Boykin. At 0 meters, you're gonna write 0 seconds. 10 meters, 5.76 seconds. Woo! 20 meters, 10.59 seconds.
30 meters, 14.88 seconds. And at 40 meters, 19.31 seconds. Wow. All right, so don't forget, our goal here for this whole lab was to really understand how to describe motion. We've used words, we have collected some data, and we've done our calculations. Now, I don't have my calculations here, but you should have calculated the speed for each of these time intervals. Now, the next thing I'm gonna do is make a graph. So I'll remind you there's some key components to a graph. We need to have our title. We need to have our x-axis needs a label and units. And same for the y-axis, a label and units. So how did I get this graph? You know, what did I do to get here? So let's go ahead and take a look at this. So I start at 0 seconds at position 0, so that's gonna be right here in the corner. And then I went 6.92 seconds for the first 10 meters. So I go 6.92 right here, and then I go up to 10 right there. So for the first 10 meters, I went 6.92 seconds. Looking back at my data, I look at position at 20 meters, and at 20 meters I went 14.49 seconds. So 14.49, that's right around here, and 20 seconds was right there.
20 meters.
20 meters. Ooh, back and forth here, Miss Moore. Okay, so you guys can see how I took the data over here and I graphed it. All right, let's go ahead and take a look at this graph in another way. I wanted to point out that this x-axis is time in seconds, and this position in meters, I want you guys to think about this as the number line, the line that we were using to walk and mark our time. So if this is the number line out on the sidewalk, I'm gonna go ahead and flip this way, right? And we were walking down the sidewalk, right? So let's take a look at what this means. So as time goes by, you can see which person hit the 10 meter mark first. You can see, oh, okay, that person hits the 10 meter mark, then that person, and then that person in this much time. Ooh, really slow.
Wow, that first person's already at a 20 meters.
Yeah, and you can see that this person has already gotten to the 20 meter mark before this person.
That's over twice as fast.
Yeah, even gets to that first 10 meter mark.
Cool.
Yeah. So as time goes by, you can see who gets to which marker fastest. Okay, you can see that this orange person is moving through the distance at a faster time, which tells us that they're moving through at a faster speed. And there we go.
Not yet, not yet, not yet, not yet.
Finally, woo!
Dang, that's slow.
Slow. So we are not going to answer the questions yet. We are going to come back to these questions once we've done about 2 more lessons. So hold off on this and realize that we're going to be coming full circle. We're going to learn a few more things, and then we're going to be able to answer these questions the best possible.